Back up here, we're doing geometric transformations with matrices today. You've done this in the past. Once again, this is kind of a review of some of the geometry stuff we did. That's where we introduced matrices with you. But a quick review. Complete the work together on page 122, questions 1 through 5. That's actually this, and question 1 says to graph it. Well, I've provided that for you, so I figured you can graph it. I didn't want to waste class time for that, so I've graphed the figure. I've actually included number 6 in there, but I don't know if we'll go into that too much. But 2, 3, 4, and 5, I want you to work with your groupies right now and complete that. You should have grabbed it on the way in. How many of you remember doing this last year in geometry? Translations, where you're sliding things, okay? It's a transformation. So it says translate our figure 4 units down, 4 units to the right and 3 units or 6 units down, label the new. So Lee's done a good job here. She's got her primes. Okay, she's got, if I just pick any single point, I should be able to go to the right 4 and down 6. So 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, and we've got E prime. So very good. Kind of tougher to see that on there, so I'm going to zoom in. All right, so Lee's got that. We have, whose is this one?
Me.
This one you? All right, so we got Colt's here, and Colt's got them labeled. And so if I pick that same E, okay, it looks like it's at the same point, but now I'm going to look at -2 to +2. Notice I'm going 4 units to the right. That would be adding 4 to -2, which should bring me to 2. And 6 units down, that would be subtracting 6 from 2. That should bring me to -4. Okay, so using our XY axis, add 4, subtract 6, we get to that coordinate as well. All right? Same thing here. This is Alyssa's? Yeah? Okay, and so we've got our -2, 2. Good. All right, and Jaden's got the same thing there. Okay, so when I'm taking a look at this, I've got Chad's here. Chad's got got a vector in there. How many remember doing vectors last year? Okay, so going from E to E, he's got a vector from there to there, and so it's nice to be able to see that you should have your 3-dimensional figure. And a quick check to make sure that you've moved all your points the same is if you connect them like that, you should see a 3D figure. All right, so, and it looks cool. I mean, I don't know if that's like exactly why you do it, but it does look pretty cool. All right, very good. How does transformation, or excuse me, identify the coordinates of the vertices in original? We've got that. How does the transformation 4 units to the right and 6 units relates to the new coordinates? Very good. Add 4 units to x, subtract 6 from y. And so without graphing, we should be able to use that information from these coordinates right here. We should be able to transfer our graph for number 5 there. Number 5 says move it 5 units, or 10 units to the right and 3 units up. So 10 units to the right means we're adding 10. 3 units up, we're adding 3. So to each of these points, if I want to find my new A, I'd add 10. So -7 and 10 is 3. And then I'd add 3. So 5 and 3 is 8. Okay? And we do that for all of them. Dylan?
How do you show like that the points on a figure are like different? Especially with those little marks above them?
The little primes?
Yeah.
So I think Lee had prime notation here. Okay, so this would be, so Lee showed that these are different coordinates by putting primes. If you're labeling the points, okay, if you're labeling the new points, you may call it, and I don't see it, so Alyssa, do you mind if I write on yours here? Okay, so if Alyssa's labeling her new points, rather than calling it A, she might call it A prime. Since we already had a prime, then the first one maybe A prime prime, and then B prime prime. Does that make sense? It's the second. Okay, so this would have been actually A prime. And now we're not going to do a lot of moving like that in here. That was more of our geometry, but that's really how you would label it. Okay. I do like this Colts. Let me give Colts back. Alyssa, very good. Thank you. Let me move hers back. Will you pass that back to Chad? Just everyone pass it back there. Okay, I'm going to talk about Lee's really quick here. On number 4, she says, how does the translation 4 units to the right, 6 units down relate? Notice she said x plus 4, y minus 6. Okay? It's a good way to think about it. You're adding 4 to every x, and you're subtracting 6. So you have an expression here that represents it. Notice that she's put hers into a matrix. This would be a resulting matrix. So if our original matrix, which is kind of what we're getting at here, if our original matrix is this, we have all of our x's and y values. So we take, this would be A, this would be B, this would be coordinate C, D, E, F, and I'm getting smaller and smaller, G and H. Okay? If those were all of our original points, let me move this so we can see it. Those were all of our original points. The new matrix, or the copy, is this the second one, Lee?
Yeah.
This was the original. So this was number 2, where we moved it 4 units to the right, 6 units down. Okay? So she's in her head, in that case, she added 4 and subtracted 6. Okay? In this one, she's kind of flipped it around, right? This represents x and y. Oh, sorry. On this one represents x and y. Okay.
Yeah.
And this would be a prime prime, where she's added 10 and added 3. Okay? What I want you to do right now is I want you to take and flip your paper over. Okay? On your piece of graph paper on the back, I want you to pick 3 points. 3 random non-collinear points.
Do we have to label our...
Well, right now, just pick 3 non-collinear points. Any 3.
But they're all coplanar.
All right. So there's my 3 non-collinear points that I've chosen. I want you now to connect those points and make a triangle. Okay, bad triangle. It's not terribly important that you have to use a straight edge, but you can. I'm going to label my points A, B, C because I'm creative like that. Okay. Now, based on that, I am going to put these points on an XY axis. So, somewhere on your paper, I don't care where it is, I want you to draw an XY axis. So, my XY axis is going to go right here. Yours doesn't have to, it can go anywhere. Here's my XY axis. I got my coordinate plane there. Label the coordinates of each point. Okay? Once you have your points labeled, I want you to write those coordinates in a matrix. That would have X, Y, and A, B, C, like that. So for instance, on mine, my A is the order pair -3, 3, so we'd have that. Okay. All right. We there? Now I want you to, without moving the figure on your graph, I want you to translate this matrix 3 units to the right and 2 units down. Okay, so your transformation matrix, if you think about it like that, would be for every x value, I am going 3 units to the right, which is adding 3. So plus 3, plus 3, plus 3. And every y value, I'd be going 2 units down, so minus 2, minus 2, minus 2. Your transformation matrix is a really boring matrix. Okay, it just really says that for each point, I'm doing this to it. So really what you end up doing, at least your paper there, is you add these two matrices together. This matrix, your original matrix, plus your transformation matrix. So if you put those two together, you get your negative 3 and 3, which gives you your resultant matrix. In this case is, for me, it's 0. Negative 3 and 3, 0. Negative, or 4 and 3. Or 7. We got 3 and negative 2, or 1. We got negative 1 and negative 2, negative 3, and negative 1 and negative 2, or negative 3. Okay. And now I want you to plot those points. This would be A prime now, B prime,
Oh, I put my...
and C prime. Now, if it won't fit on yours, if it won't fit on your graph, I guess you won't be plotting it, right? I did tell you that you're going to be moving things around, but hopefully if you were to add another piece of graph paper, if you have one, you can set it aside and try to plot them. Okay? So 0, 1, Mr. Rosenbaugh, how are you?
I'm doing well, Mr. McCoy. Yourself?
Amazing. Matrices.
Very exciting.
Yeah? They love it. Can't you tell? They're pumped.
They look excited.
Yeah. Okay, B prime. Who said not really?
Not me. Not me.
Jeez, man.
Hannah, she's the most excited in here.
All right. There we go. So mine, that would be my resulting. If I was to use the chat approach there, I could double check it by actually drawing some cool guy vectors. See the 3-dimensionality of it. Okay, now the goal is for you to not to have to draw it every time. Okay? All right, so a bit of vocab. Transformation matrix, resultant matrix. We have our original matrix. Okay? All right. Hey, I want you to do another thing now. Any questions on that? Okay, I want you to do another thing. I want you to take your original matrix, rewrite it somewhere where you have a clean place on your paper. Your original. Your XY. Okay, so my original matrix was negative 3, 3, negative 3, negative 1, and 4, negative 1. All right, so my original coordinates there of A, B, C. All right. I now want you to make that figure. I want you to dilate it. Tell your neighbor what dilate means.
Tiny or bigger on a scale?
Good. So dilate means you make it bigger, you enlarge it, or you reduce it. You make it smaller. So I want you to dilate it. Did I spell that right? That doesn't seem right.
It's D-I-A-L-A-T-E.
Ah, that's why. There we go. Dilate. Hey, okay, we're going to dilate at a factor of 2. A factor of 2. Now, is that going to be a reduction or an enlargement? Good. So another way of saying that is enlarge. Oh my goodness. Enlarge. Enlarge at a factor of 2. Go for it. Write your resulting matrix. Now, you guys, you're not graphing it. Some of you can graph it, but many of you drew big figures. That's why I had you draw them before I told you what we're doing. So some of you can't graph them, right? Some of you can. But when you're enlarging, you're dilating by a factor of 2. Really, what are you doing with your matrix?
Multiplying it by 2.
You're multiplying it by 2. So if I took this matrix right here and I multiplied it by 2, it's scalar multiplication, right? So 2 times negative 3 is negative 6. 2 times 3 is 6. Negative 6, negative 2, 8, and negative 2. Those are my new coordinates. That would be my A prime, and since I've already had an A prime, I'll go A prime prime, B prime prime, and C prime prime. Okay? That would be my enlargement. Those are the coordinates of my enlargement. Negative 6, 6. Negative 6, negative 2, and 8, negative 2. Be C prime prime, B prime prime, and A prime prime. Now I could check that because I have enough room on my paper. If I were to plot those points, I'd see a figure twice as big. Okay? Tell your neighbor how that would change if I was going to reduce it by a factor of 1/4.
You would divide every single element by 4. 4? Because you said 1/4.
Okay, if I am reducing by a factor of 1/4, what am I actually doing? Dividing by 4. Usually that's what I end up hearing is you divide by 4. Now, is there a way to actually multiply to get that?
Multiply by 1/4.
Good. If I'm reducing by a factor of 1/4, I could actually multiply it by a quarter. Okay? So looking at mine, what's 1/4 times negative 3?
Negative 3/4.
Good. It's just top times there divided by bottom. Negative 3, remember, like that's a fraction. Negative 3/4. What's 1/4 of 4?
1.
What's 1/4 of 3?
3 over 4.
Okay, I'm hearing 2 people. What's 1/4 of negative 1?
Negative 1 over 4.
Negative 1/4. What's 1/4 of negative 1?
Negative 1 over 4.
Okay, so those are my new coordinates. My figure would get smaller. It would reduce. Okay? If I actually plotted those, negative 3/4, 3/4, negative 3/4 is here, 3/4 is here, I've got that point there. Negative 3/4, negative 1/4. That's like right, hold on. Negative 3/4, negative 1/4, like right there. And then 1, negative 1/4, like right there. So my figure is like a, oh, isn't that cute? It's like a little mini triangle. Okay? And you guys don't see it. Thanks for there. All right.
Oh.
Isn't that cute? It's 1/4 as big. Each side is 1/4 of, oh. And it is a cute, well, it's actually right too. That is right. A cute, right? All right. Any questions? So scalar multiplication today and transformation matrices today. Here's right here. Hey, Dylan had a good question. He's like, do you have to label all your matrices? You don't need to do it for my sake. You should always circle your resulting matrix and then make sure that if you're being asked to put the ordered pairs, that this is not the ordered pairs, right? If you have matrices, these are not your ordered pairs. These are your ordered pairs. Okay, so note if it asks you to say leave it in matrix form, which is this, or leave it in ordered pair form. Okay? The only time when I'm doing this, if I'm listing my original matrix, my transformation, and my resultant matrix, I might just for my sake write a big O above this one and a big T above that one, a big R above that one. That way I know what those represent. Like when you're looking back at your work, the more you deal with this type of stuff, the more you want to be able to look back and go, oh yeah, this is what I meant here. Okay? as you progress, math gets more and more complex. The less you leave trails for yourself that you can follow, the harder it is. So those of you who write like Picasso on your paper, you do a problem and then you turn it and you do another problem, then you turn it and you do another problem, and you're like done, you're like, dude, look at all those numbers. That's really cool looking.
Yeah.
Okay? And number 7 is, it's somewhere. I can't really figure it out, but it's there. McCoy, it's there. Trust me. Okay? That's going to be a lot more complex for you in the future. Okay? You really need to get organized with it. Okay, your assignment today is going to be the example side. Odds up to, I'll let you do odds only up to number 17. So 1 through 17 odds. And then 18 through 20 all. So your assignment before you walked into class, before you participated most of the time, with the exception of the last few questions, was all. But since we were able to show that we could follow along and have some discussion, we went to 1 to 17 odds plus 18 through 20 all. Okay? And then don't forget your pre-quiz. That'll help you tomorrow, I promise. All right? Questions?